Next is positive moments at midspan. So that is bars 3 and 4. So yan yung mga bakal sa gitna ng slab. Yan yung mga bakal na nasa ilalim. Yung ginawa natin kanina 1 and 2, yan yung mga bars na malapit sa surface ng slab. So positive moments, ito yung mga moment diagram na naka-curve upwards. So ganon din, you have table 3 and table 5. In the sense na table 3 deals with dead load, table 5 deals with the live load. This pertains to dead load positive moments, short direction. With 0.9 and 0.95, and case 4, we have 0.033 and 0.03. Yan, ito siya. Okay? And then by interpolation, you have CAD 0.0322. So, you store that to X. And then, punta tayo ngayon sa table 5 naman. Yan ay para sa live load. Okay? So, again, you have 0.9 and 0.95 at case 4. You have 0.039 and 0.035. Ito siya. So, by interpolation, your coefficient is 0.038. You store that to letter Y of your calculator. And then, this will be our equation for moment, which is equal to CAD times 1.2 dead times LA squared plus CAL times 1.6 live times LA squared. Wherein your effective depth D is equal to H minus clear cover minus diameter of bar minus dB all over 2. Okay, so remember na ang CAD natin ay nakastore sa X, tapos yung CAL nakastore sa Y, tapos ang DL ay 6.15, remember that? Tapos ang live load is 4.8. Nandun yan sa given. And then LA is 5.25. And then you multiply all of those, you have 14.588 kilonewton meter. And then proceed to computing RU. But this time, ang gagamitin natin ay DY. Okay, remember na ang dy is H minus clear cover minus dB all over 2. So, you get 2.14, you store that to A. And then, you compute your required draw, same equations, and you get 0.01004, which is greater than rho min, kaya okay yan. Now, you store this to B of your calculator. And then for required S, same equations as before, but this time you still use dy. And then you have 129.53. You still have to round down. So, magiging 120 yan. So, this becomes now S3, meaning this is for bar number 3. And then you check your spacing. Equation for spacing, ito siya, but you have to use spacing of 120 and your dy. Okay, so dy is 87 mm. Now let's go to bar number 4. For bar number 4, same pattern with bar number 3, but this time you will be using table 4. Ito siya. So 0.9 and 0.95. Case 1, 2, 3, 4, you have 0.022 and 0.024. Ayan siya. So, your CBD, so that means in the long direction, yung subscript na B, tapos D sub, that means dead. So, you have 0.0225, you store this to X. And then on table 6, eto siya. Table 6.9 and 0.95, case 4, you have 0.026, 0.029. Your coefficient for CBL is 0.0268. You store that to Y. So, ganun din, kunin mo yung dead load tsaka yung live load galing sa given. But this time, you will be using LB. So, that is 5.75. And you get MU 12.296. Then you compute your RU and then your required draw. But this time, you will be using dx squared. Again, take note, ito yung bakal na una nating nilagay. So, mas malaki ang effective depth nito. So, that is dx is equal to height or thickness minus clear cover minus dB all over 2. This is 99. So, your required draw is 0.00637. That is greater than raw minimum. So, okay. You store this to letter B of your calculator. Then, you compute your required spacing again. Tapos, dx pa rin ang gamit niya. Lumalabas na 179. You have to round this down as usual. So, magiging 170 siya. So, that will be your S4, meaning spacing ng bar number 4. And then, you check your spacing. This equation, 0.00672, this is less than raw max, meaning hindi siya nag-exceed. Kaya, okay siya. So, natapos na natin yung spacing ng bar 1, bar 2, bar 3, and bar 4. But, take note na si bar 2 tsaka bar 4, actually, isang bakal yan na diretso hanggang sa bar 6. Na-bend lang siya dito. Likewise, si bar 1 tsaka si bar 3, in reality, isang bakal lang yan. Pati itong bar 5, isang bakal pa rin yan. Binend lang yan, mano-mano. Now, we will proceed to bars 6 and 5. Ito yung mga negative moments at discontinuous edges. Ang moment nito ay 1/3 nung opposite moment. Okay, let's compute moment 5. Moment nung bar number 5. Ito. So, top bars parallel to short direction at discontinuous edge. The MU is 1/3 nung MUA. Remember that MUA, ito yung moment ng bar sa positive. Okay, so ito siya. MUA 14.588 divided by 3 will give you 4.86. Tapos, computein mo yung RU. Ngayon, lumalabas na ang required draw mo is less than raw minimum. Meaning, you have to recompute using these two conditions. Your raw should be the maximum of these two conditions, which is raw minimum, and 4/3 of 0.00246. Ang raw minimum ay 0.00614. So, lumalabas na yan ang maximum among these two conditions. Meaning, hindi ka pwedeng mas maliit. So, we will be using this 0.00614. And then, your required spacing would be this. Take note na yan yung bakal sa discontinuous edge. So, ang gagamitin natin ay effective depth D. Walang subscript na X at wala ring subscript na Y. So, that is 99 mm. So, lumalabas na ang spacing mo ngayon ay 186.05. So, round down, magiging 180 mm. So, yan ang ating magiging S5. Again, you check the spacing. So, your steel ratio is 0.00635, which is less than raw max. So, okay siya. Same procedure with bar number 6, top bars parallel to long direction. Likewise, sa bar number 6, ito yung 1/3 ng positive moment. So, bar number 4, magiging 12.296, okay, that is MUB divided by 3, will give you 4.10 kilonewton meter. And then you proceed as in singly reinforced beam. You have RU. As usual, ang mga negative moments at discontinuous edges, ang kanilang required rho is most of the time less than rho minimum. So you have to compute your rho. Also, most of the time, mag-govern ang rho minimum, which is 0.00614. So you have to recompute your S. Before going to extra bars, summarize muna natin yung bars 1, 2, 3, 4, 5, 6. So, dito, yung bar number 1 is top bar parallel to short direction at continuous edge. Kunin natin yung S1 which is 80. Ito siya. And then, number 2, top bar parallel to long continuous edge. Your S2 is 100. Ito siya. Same thing with number 3, bottom bars parallel to short direction midspan. Your spacing is S3 na 120. Ito siya. And then yung S4, 170. Tapos, S5, that is negative or top bar, parallel to short at discontinuous. So, S5 is 180. Likewise, S6 is also 180. Remember na yung spacing ng temperature and shrinkage bars na sinolve natin noong una is 310 mm. Ito yon sa bar number 7. Temperature and shrinkage bars, 10 mm, top and bottom, both ways, 310 mm. Yan ang spacing niya. And then, ito yung figure. Remember na L sub A is the unsupported short dimension, and then L sub B is the unsupported longer dimension. Tapos, ito yung the bar number 1, ang spacing niya ay 80. Ito yon. So, top bars na nakapatong sa continuous edge. Ito siya. Tapos, yung bar number 3, yung karugtong ng bar number 1, is magiging bottom bar parallel to short dimension is 120. Tapos, yung karugtong naman niya ay bar number 5. Yan, ang spacing niya ay 180. So, notice na, in reality, bars 1, 3, 5, isang pirasong bakal yan. Straight bar ang tawag dyan. Ibebend lang dito mano-mano. Pero magkakaiba ang kanyang spacing. Now, we will fix that later. Now, let's go to bars 2, 4, 6. By the way, ang tawag sa 1, 3, 5 na bakal, yan ay transverse bars. Or, transverse simply means it is perpendicular to the longitudinal or longer dimension. Now, let's go to bars 2, 4, 6. Ang tawag dyan sa bars 2, 4, 6 is longitudinal bars, or it is simply the bars parallel to the longest dimension. So, bar number 2, ang spacing niyan ay 100. Then, bar number 4, 170. And finally, bar number 6 is 180. Tapos, itong mga red, take note, yan ay temperature bars spacing na may 310. 310 sa top, 310 din sa bottom. So, in short, i-multiply mo ng 4, yan. But we will solve that later on. And then, dito sa longitudinal bars, Remember na yan ay bars 2, 4, 6. Tapos, yung moment ng bar number 6 is only 1/3 nung moment na binubuhat ng bar number 4. Kaya, obviously, ang spacing ng bar number 6 ay nasa minimum lang. Actually, yan ang pinakamalaking spacing. Dito tayo ngayon sa longitudinal bars. So, normally, ang magkalapit na spacing, almost parehas na spacing ay spacing ng bars 4 and bar 6. Itong bar number 2, iyan yung pinakamabigat na moment. Kaya, bar number 2, yan yung mas maliit ang spacing. So, in short, kukunin natin ngayon yung spacing or common spacing ng longitudinal bars. Ang tawag natin dyan ay S sub L. So, since bars 4 and 6 ang magkalapit ang kanilang spacing, which is this, S4 and S6, so 170 and 180. Tapos yung 2, 100. So, masinsin ang spacing dito sa 2. Ang kukunin natin ngayon yung minimum among 4 and 6. So, pagpipiliin mo yung 170, 180, magiging 170 ang S sub L natin. Okay? Ganun din sa transverse. Sa transverse naman, ang pinaka masinsin ang spacing ay bar number 1. Bars 3 and 5, magkalapit lang ang spacing niyan, which is 120 and 180. Okay, so again, 3 and 5, kukunin natin yung minimum dyan, which is 120. Ang tawag dyan ay S sub T. So, T stands for transverse and L stands for longitudinal. Now, going back to longitudinal, since yung bar number 2, masinsin ang spacing, kailangan nating, pero ang gagamitin nating spacing dito sa longitudinal bar ay S sub L, which is 170. Compare that to 100. So, ibig sabihin, kulang yung spacing. Kaya magdadagdag tayo ngayon ng extra bar dito sa bar number 2 tsaka sa bar number 1. So, sa bar number 2, ang tawag sa spacing ng extra bar ay S sub A. Sa transverse naman, ang tawag sa spacing ng extra bar ay S sub B. So, we will be computing the spacing of those extra bars. For longitudinal extra bars, ang equation niya ay rho 2 is equal to this equation. Take note na yung S sub L ay 170. S sub A ang ating spacing ng extra bar. And then A sub B, that is 113 or area of one reinforcing bar. And then your B is 1,000. Constant yan sa 1,000. Tapos D is 99. And then rho 2, kukunin natin yan sa bar number 2. Dito. Yan. Okay, so remember this is bar number 2. So rho 2 is equal to 0.010999. Likewise, ipapasok na natin siya ngayon dito. So rho 2 times BD divided by area bar minus 1,000 over S sub L. Tapos si cross multiply. So lumalabas na S sub A is 267. Okay? So remember na yan ang spacing ng extra bars. But just to be sure, or just for conservative reasons, ira-round down natin yan by 10 mm increments. So magiging 260 mm.